For this real world context, I think most people they got quite stuck in it during the actual exam because there's a lot of information. Yeah, I agree. This question involves a lot of information, and if you are not able to organize the information and then do accordingly, you'll find that it's very, very time consuming. Okay, so be patient. They read the whole thing, and then you don't need to start straight away. Okay, so for example, when I try doing it, right, okay, I read, and then right, I make sure I know the ultimate aim. The ultimate aim is to find the area of the solar panel. Because if I'm going to put it in my house, I need to estimate how much area that I will need for the solar panel. And the condition is right, the solar panel must be enough to generate the electricity in the household. So I need to make sure I have the space for the panel, and I also the panel must be able to generate the amount of electricity that I need. Okay, and then the information is quite that he finds on the internet. Okay, will be you actually need to know the average amount of electricity that you will use in one day. So if you have no idea how much you are using, right, then you won't know how much is enough for you. So you need to know the average amount of electricity that you use, and the measurement is kilowatt. There is a definition on kilowatt and the conversion as well. So you need to take note. Okay, so there is a conversion and also what is 1 kilowatt. Okay, 1 kilowatt is the energy used by an appliances in 1 hour with a rating of 1 kilowatt. But of course, some appliances, uh, different appliances will have different power rating. The higher the power rating, that means it uses even more uh, electricity per hour. So there are like for example, aircon actually use quite a lot of energy. Okay, so look carefully at the definition. And then of course, if you need to know how much you need to use, if you have a very big household, of course you need a lot of electricity. Okay, secondly, because the idea of solar panel is they trap the sunlight. So you need to find out the peak sunlight hours. That means, right, how many sunlight hours that you receive. In some countries, they don't have a lot of sunlight hours because they actually have their sunset very early. So locally, our sunset is around 7 o'clock. But in some country, it can be 5 o'clock, 4 o'clock, and it depends on the season. So the sunlight hours that is being received is not the same every day. Okay, so we also need to factor that in. So it couldn't be such that on the days where you don't have a lot of sunlight, you don't have enough electricity to use. So that is part of the consideration. Okay, then another important information will be the formula to calculate the solar panel output. So this one is important. You need to rely on this formula to calculate how much your solar panel, how much your how much energy your solar panel can give you. So this is the formula for you to calculate how much energy your solar panel can give you in a day. It's a daily thing. Okay, and then another assumption is all the solar panel can be the same, must be the same type. That means I cannot be mixing. I cannot be mixing this type and another type. Okay, so I must just decide on one. It's something like the aircon in your house. Okay, everything must be the same brand, same setting. It cannot be like your room is using a bigger aircon and another room is using a different type of aircon. Okay, so that is the same idea here. Okay, then subsequently, um, uh, we have this bar chart about the peak sunlight hours as in terms of the month. So you can see there are some months, right? you do not have so many sunlight hours typically in the year end. You find that year end, you do not have so many sunlight hours. Okay. So this is the average daily by month. So it's quite possible to read off. It's quite possible to read off. So this one is 4.7, this one is 4.9. You can actually list it out. It's actually possible. It's quite easy to read. Okay. So we will see how we're going to be using this later on. And then we also got 4 types of solar panel. Okay, so this is the power of the solar panel. So this is the one that we will be using in the formula. Okay, and then this part here later on will decide the area. Okay, so it's something like for example here is like a rectangular piece. So it's like 1.46 meter and 1.05 meter. So each piece, so first of all, I need to decide how many pieces I need. And then after I decide how many pieces I need, how much area all that is involved. Okay, they gave the mass of the panel. So this one may come into consideration. We will see how. Because if let's say there are 2 brands that you can use, you might prefer the lighter one so that it's easier for the installation. So that can be also part of the consideration. So, but the ultimate consideration will be eventually you must be able to estimate the area of the solar panel, and the area must be sufficient to supply the whole household. Okay. So, okay, we will try to answer the question first. Usually the first 2 parts of the question is meant to help you in the final part. Okay, so like for example, part A, a game console has a power rating of 165 watt. So if you recall what is the power, what is the rating? So that means, right, this is the amount of energy for 1 hour. Amount of energy used in 1 hour. So that is the definition that is given. That is the definition that is given here. So since it has a power rating of 165, that means in 1 hour, it will consume 165 watts of energy. So we want to know the energy in kilowatts for 5 hours. So that is just simple math. You just multiply by 5. But when you multiply by 5, it's in watts. So you need to convert to kilowatts. So that one is quite simple. Okay. Now the second part. Now assuming all the months have equal numbers, calculate the average daily peak sunlight over a 12-month period. So we are going to be averaging out for these 12 months. So to average out, you actually need to total. So you actually got to start reading each of them first. And then you get the total sunlight first. You get the total for the 12 months. And then you divide by 12. Okay, so totaling up is not difficult. It's just that you got to read one by one and you got to add up one by one. Okay, so you do take note. You will get 4.44 as the answer, but 4.44 is a round off to 3SF. So for this part, I am trying to have the exact fraction because later on I will need it in my formula, the peak sunlight hours. So in the formulas, right, later on I'll be using 533 over 120 as the peak sunlight hours to calculate the solar panel output. Okay. Yeah, so that one, this part is not difficult, it's just a bit tedious that you need to read off every single bar chart and then you add them up. Okay, then another one. This graph shows the electricity by Chen's household for the past 4 years. So he observed the trend in of the use of electricity. So basically, some months he didn't need to use so much. There are some months that he used a lot. So to make sure that the solar panel can give enough, we will use the maximum. That means I'm not going to average. I'm not going to count every single one. I'm not going to count every single one. So to me, right, if I look at the highest amount, and if the solar panel can cater to the highest amount, then it should be safe when he don't need to use so much. So I actually ignore all the data here. I only look at the maximum. I only look at the highest, because if my solar panel can cater for the highest amount, when he don't need to use so much, he surely will have enough. So I read, this one is a little bit more difficult to read. You need your ruler, you got to put it there to read the fall amount. So in each of the year, right, I'm going to factor in the highest, so that to ensure that I will have enough. So of course, we will not be using the lowest. If your solar panel can cater for the lowest, that doesn't mean that the solar panel can cater to you when you need a lot. So you cater for the max, and then you will surely be enough for the months that the days where you don't need to use so much. So I look at the max power for the 4 year. Okay. And then if I look at the max power for the 4 year, right, I can calculate an average for 1 year. So this average will be more than is the max. So since I'm using the max, right, that means if my solar panel can generate this amount, then I will be quite safe. Okay, so I think there are some students who might want to take the middle. Some students will take the highest and the smallest and then divide. So some students will take the average. Well, it is still okay if you decide to take the average, but definitely not the lowest. But the safer one will be to take the maximum. So that's why when I do it out, I actually use the maximum. The maximum will ensure that when you don't need to use so much, you will still have the same enough energy. Okay. And then because the formula relies on because the solar panel output will be calculated in a daily, how much the solar output can do. So I'm going to calculate the amount of electricity that I need each day. So after I find out the average max electricity for 1 year, I will calculate the average amount of electricity that I need to use in a day. So I choose to divide by 30 months of 12 months of 30 days. But of course, it can be 365 days. It's fine. So you must know that this is the amount of electricity that you need every day. And your solar panel must be able to provide this every day. So based on this, right, I'm going to calculate how many pieces I need. Okay, so this is the troublesome part. Because you got 4 solar output, you got to apply the formula on this 4 solar output. Okay, so you use the formula here, the solar panel watt times the peak sunlight times 75% to calculate one piece of panel, how much energy. So I'm going to do it like one by one. So one piece of A, so when I say output from A, right, I meant one piece. So if you use the formula on solar panel A, you find that one piece can provide this amount of energy every day. So if you use this formula, one piece of solar panel A provide this amount. But because he needs this every day, so if the needs of electricity is fixed, And if one piece of A can provide this, right, then I got to calculate how many panels do I need, how many pieces. So I will need 8 pieces. So I do the same thing for one piece of B. How much energy can I get from one piece of B? So in this case, if you look, I apply the formula, it has a higher watt. So it actually provides more energy. So because it provides more energy, I do not need so many pieces. I just need 7 pieces for the need. So this one, the daily electricity that you need divided by whatever the solar panel can give you. So I continue to do the same thing for C and D. So you will realize that C and D, because they got a higher output, so every piece, right, they are going to generate more power. So the more power one piece of solar panel can generate means you don't need to buy so many pieces. Okay, so so in this case, if you work out the number of pieces, right, 6, both of them will need around 6 panels. Okay, so you got to buy whole number of panels. Okay, so if you compare all this, you find that C and D is the one that you do not need to buy so much. Okay, so in such a case, if you are choosing between C and D, you can eventually decide which one is the lighter one. So if you, maybe you are thinking, you will want the heavier one or something, so you can justify it. But logically speaking, if we were to choose in real life, we want the lighter one so that it's easier to install. So usually people put it on the roof. So you do not want so heavy stuff on the roof, as light as possible. Okay. So once I chose D, then based on the dimension of D, I can work out the area that is necessary. Okay, so in a way, it looks very complex, but somehow if you break it down, you realize that it's not so bad. Okay, we will need to use the formula idea, and from the data, there's a lot of ways to get the data. So a lot of ways to interpret the data. Okay, so like for example, I think so if let's say you use some variation, you might find that the answer can differ a little bit. It doesn't matter as long as you justify. So like for example, some people, if they use 365 days, then maybe the amount of electricity each day will differ a little bit. Okay, so you look through the whole idea. Eventually, it's not that difficult. It's just there's really super lots of data for you to process.